Hi, my name is Bob Pagano, and what I'm trying to do is help you become more familiar with my textbook in the attempt for you to be better able to familiarize professors with the textbook when you're visiting them, with the end goal that if they're interested in what you show them, that they take a further look at my textbook. Personally, since I've written it and I'm quite biased, I think it is worth looking further, and I don't think you will be embarrassed by any of the professors that decide to do so. I've been teaching a course, and I'll read some of this because I just think it comes over better. I've been teaching a course in introductory stat for more than 30 years. First in the Department of Psychology at the University of Washington, and most recently in the Department of Neuroscience at the University of Pittsburgh. Most of my students have been psychology majors. Many have come from biology, business, neuroscience, nursing, and many other fields. My introductory stat class has been rated very highly, and while at the University of Washington, I was a finalist for the university's Outstanding Teaching Award for teaching this course, and by the way, using this textbook, which was the mainstay of the course. I think it's fair to say that my textbook has been very successful. It's going into its 10th edition. It's one of the top 2 selling textbooks in its statistical niche. That is to say, it's not a newcomer trying to find its place. It's a field-tested stat book going into its 10th edition. Student ratings have been very high. Among other things, students say that the book is very clear, that they like touches of humor that's in it, and it helps them to have the material presented in great detail, which it is in my textbook. There even have been comments like, "This is the best textbook that I have ever had." I will have to admit that isn't the most frequent comment that I have gotten, but for a stat book, I think that's pretty good going. Now, to some specifics about my textbook that might be useful to point out to professors. Probably, in my opinion, the most important point is that compared to other textbooks, my textbook uses a more extended treatment of sampling distributions and a particularly effective sequencing of the inferential material, beginning with the sign test instead of the conventional approach of beginning with the z-test. The extended treatment and sequencing promote an understanding of the inferential process, with the result that students understand what they are doing rather than just performing rote problem solving. So my book is not about rote problem solving, it's about understanding statistics, and the most difficult thing to understand in teaching an introductory stat class, in my opinion, is the inferential process, which takes up about half of the term. And without this extended treatment, I think it's fair to say that many, if not most students, do not understand what they're doing in inferential statistics and just rotely problem solve. It might be useful when with a professor to just page through the textbook quickly, showing them the sign test chapter, the next chapter, which is power, followed by the Mann-Whitney U-test, followed by the chapter on sampling distributions and the z-test, which is where most conventional textbooks begin. Just to point out the extended treatment. They can read it themselves if they want to and make a judgment as to whether they feel it's useful to go that route. Another important point that many folks have commented on is that my textbook is student-friendly, informally written, with touches of humor that connect with students and help lower anxiety. And as an example of that, I'll just read you a short part from the beginning of the textbook, first chapter. It involves the discussion of how we know that something is true, and it discusses at this part rationalism or rational thinking as a method of knowing, and of course talks about the syllogism. This is the syllogism. All statistics professors are interesting people. Mr. X is a statistics professor. Therefore, Mr. X is an interesting person. Assuming the first statement is true, that is, all statistics professors are interesting people, and who could doubt that? Then it follows that the second statement is true. If the second statement is true, the conclusion must be true. Therefore, if someone is a statistics professor, they must be an interesting person. I'm sure your professor would agree with that syllogism, the one you're talking to. It doesn't attempt to present a real in-depth presentation of the rational approach, but give good background information at an informal and humorous level, and that tone is kept up in many parts of the textbook. My textbook has also been complimented in that it's very clearly worded and written at the right level. Writing at the right level is critical for this audience. If it's too low, they get bored. If it's too high, they get turned off. It's very easy to turn off psychology students to statistics. Of course, not sales rep. They are really into statistics. But for psychology students, the level of wording is very important. And I believe, and many people have told me this as well, my book is written at the right level and is clearly worded. I can just read a brief example of that. This is an example that comes from I'll get there here, 289. This is Chapter 12, which is the sampling distribution chapter, and it's sort of summarizing the inferential process. And what it says is, generalizing from this example, it can be seen that data analysis basically involves just two steps. Number one, calculating the appropriate statistic. For example, the T statistic, or the Z statistic, or the F statistic. And then the second step is evaluating the statistic based on its sampling distribution. Just those two steps. If the probability of getting the value of the statistic, or a value even more extreme, is equal or less than the alpha level, then we reject chance. And we accept that there's a real effect of the independent variable. If not, then we retain chance. The process applies to all experiments involving hypothesis testing. What changes from experiment to experiment is the statistic used and its accompanying sampling distribution. So if a student understands just this basic process of inference, it applies throughout the rest of the textbook of inferential statistics, whether it's the Z statistic we're computing, the T, the F, a chi-square statistic. The sampling distribution and its application is the key to understanding inferential statistics. Another point that has been raised in support of my textbook is that it has good visuals. I'm pretty proud of the visuals. I'll just show you one that I like. It's figure 18.1 on page 507. These are all 9E pages, 9th edition pages. I'm sorry to say 10th edition isn't out yet, or the pages. But that's what it looks like. This is the summary chapter of my inferential section. It's rather unusual to have a summary chapter. I find it very useful because it brings together all of the inferential material. And one of the things a student needs to know is, when presented with an experiment and the data from that experiment, how do we go about analyzing whether there's a real effect of the independent variable? We've got all these statistics that are at the bottom row here to choose from. The Z test for single samples, the T test for single samples, one-way ANOVA, Kruskal, da-da-da-da-da. There are all of these that are covered in the textbook itself. Well, how does a student know what's the appropriate analysis? And this is a tree diagram that gives the process for deciding. So there's a statement of the experimental process. The first thing you ask is, what's the measurement scale of the data? If it's nominal, you go in this direction. If it's other scaling, you go in this direction. If you go in this direction, then you ask, what's the experimental design? And there are three basic designs. There's a correlated groups design, there's a single sample design, well, there are four. There's three, I would say, if we want to look at it there. Single sample design, a correlated and independent groups design, a two-group design that's either correlated or independent, and then there's a multi-group design. So depending on what the design is, then one just follows the tree structures and eventually winds up at the appropriate test depending on assumptions being met for various tests. So this provides an understanding and synthesis and summary of what the student has been studying for the whole second half of the statistics course in visual tree section form. And students have commented a lot that this really helps them tie together the material. Another point that's, I think, important to mention is that this textbook has interesting illustrative examples and many ideally solved and interesting end-of-chapter problems for students to practice on. And there are many that I could point out. Most of them are too long, really, to read here or tell you about here. But I'll point out the introductory one in some little description so you can get a feel for this. The format of the textbook is to introduce a new statistic in each of the chapters and to introduce that statistic via an experiment. So the student gets engaged in the experiment and the hypotheses that are being tested, and then is involved in deciding, well, how, given this experiment and these data, can I conclude with regard to these hypotheses? The first one deals with marijuana in the treatment of AIDS patients. Well, a lot of students, I'm told, are interested in marijuana. And they're also interested in ethical behavior and have a position with regard to whether marijuana should be legalized or not. In this case, this example just takes a part of that and investigates the use of marijuana in the treatment of AIDS patients. So let me just read a part of this. As a scientist, you realize that although personal reports are suggestive, they are not conclusive. Experiments must be done before one can properly assess cause and effect, in this case, the effects claimed for marijuana. This is very important to you, so you decide to embark on a research program directed toward this end. The first experiment you plan to investigate is the effect of marijuana on appetite in AIDS patients. Of course, if marijuana actually decreases appetite rather than increases it, you want to be able to detect this as well, because it has important practical consequences. So this is an attempt to get the student involved and interested in the problem and learning its outcome. You plan to, the first experiment will be a modest one. You plan to randomly sample 10 individuals from a population of AIDS patients who are being treated at your hospital. You realize the generalization will be limited to this population, but for many reasons, you are willing to accept this limitation for this initial experiment. After getting permission from appropriate authorities, you conduct the following experiment. And then it goes on to describe the experiment and talks about the data that's collected, and then goes on into an analysis of how we can conclude based on these data whether the marijuana really does have a real effect on appetite. A further point is that our textbook promotes understanding rather than mechanical problem solving. There are many examples of this, unfortunately, on the tape. We really don't have time to, or I don't, to read or show you those. So I recommend, if you're demonstrating this to a professor, to read to them the section on page 277 and 278 in the Power Chapter 11, which gives the analogy of the power of an experiment to looking at the synapse and whether there's a connection between the dendrites and axons that can account for facilitated performance with repetition. I think it's a very good analogy for power, and it clearly goes towards understanding what's going on in the concept of power rather than just a mechanical computation of the power of an experiment. In the 10th edition, we've added extended SPSS coverage. There's now SPSS coverage at the end of chapters 2, 3 through 7, 13, 14, 15, 16, and 17. The coverage in each chapter begins with an illustrative problem and solution, and then there are at least 2 SPSS new problems per chapter for students to practice on. With the 10th edition, students can now learn SPSS, assuming they read the new SPSS Appendix E in the textbook as well, and they can practice on relevant chapter problems without any recourse to outside material. So if an instructor wants to have students learn SPSS in addition to the rest of the material, this textbook is entirely sufficient, I believe, except, of course, for the SPSS software, which has to be provided. No additional sources necessary. A rather unique part of my textbook involves sections that are in the textbook throughout various chapters called What is the Truth? And end of chapter questions on these sections. And these sections and questions are intended to illustrate real-world applications of statistics and to sharpen applied critical thinking. There are various chapters throughout. I might suggest the one that is kind of sort of easiest to demonstrate, or at a first glance, it's just this one on page 13, which is the first What is the Truth plate. It's called titled What is the Truth? Data, where are the data? This is an advertisement taken from Psychology Today, and it's about the effect of hypnosis on weight loss, and it claims all kinds of things about how effective it is, and it asks the student what's missing. And as you might guess, what's missing is any data attesting to back up or justify these claims. And the question is, why are there no data there? And is this a valid way of justifying, according to scientific method, purported truth claims? Well, there are chapters throughout, or plates or sections throughout the textbook that attempt to show in practice what's going on relevant in the real world to the use of statistical analysis, and then questions in the textbook tie into those sections. And then I think I'm near the end. In fact, I would be at the end if I can't find this last page, but in the 10th edition, we now have integrated the Applia application with the textbook EOC, end of chapter problems, and we have on Applia a set of tutorials I think the best way to expose the professor to this would be to show demonstrations, online demonstrations of both the tutorials and the at least the demonstration problems for the Applia tool. And if all of that is done, then I wouldn't be surprised if the instructor says, send me a copy for me to look at. And if not, you can feel happy that you've really shown what the book is about, and it may be that this book doesn't suit the instructor. But it's a very good undergraduate textbook. It's got a very good track record. Students have liked it very much. It has a lot of good things going for it. And I just stand on the book itself and hope that you'll be able to illustrate enough of its features to an instructor that they'll be interested in looking into it further. So thank you for your attention, and if there are other things that would be useful, you might mention them to Tim. I guess what I want to convey to you is that this is a good product, and if you expose the instructor to the product, I think it will be getting its fair trial, and I have good feelings about what will result from a fair exposure to the instructor. Thank you.